measurements. And this is basically where we put monitors on vehicles, and then a driver would have to drive around the community to be able to look at the measurements as they drive around through the community. So this does allow for wide area monitoring surveys and the community scale. And this is usually very beneficial for identifying hotspots or potential sources. So if there was something of a high magnitude that would be a potential source, this would be a good way of finding it. Some of the limitations is that there could be less number of pollutants measured depending on what the community would like to measure for. And also it's while good for methane, some of the techniques are not really great for especially the BTEX compounds. So there would be some limitations of the information that you would get off of the mobile monitoring. The other gap for this type of technology and approach is that it wouldn't necessarily be connected to a real-time public notification system, so and wouldn't have that 24/7 coverage because the person actively would have to drive. And typically, in this type of monitoring, we use it typically in responses to the complaints, or if we're trying to get a general profile. So you see here pictured Acoma, who does kind of the local scale gradient kind of studies that would do kind of maybe once a month or every other month through the community to get that mobile survey and collect the data. So some examples of the data that you may have seen, these are ones that were conducted by the South Coast AQMD mobile platform, doing methane throughout the communities and also within the facility to be able to give that information. There's one deployment where we didn't see elevation through the communities, and then one where you can see that there were some elevations in the community during the time of the leak. The last one I'll talk about today is about aerial platform measurements. And typically these are research instruments on board of aircraft that fly over the facility and other areas, or the community and potentially other facilities. The advantage is that they can survey very large areas on kind of regional scale, and they can detect that plume and quantify a little bit better the emissions since they're getting what's going up above the facility. They can also detect for a wide array of gaseous pollutants, methane and VOCs, but they also have some limitations that they're also a snapshot of a specific time of the time they fly over. And a lot of times they try to schedule different measurements, so the timing may be not necessarily as regular for doing these type of flights. Also, the data analysis time is a little bit longer because they will typically fly and get a whole bunch of data and then have a person go through all the data and be able to look at it. So it would not be necessarily a real-time notification associated with the aerial platform. Some examples of this that you may be familiar with is like during the leak, Scientific Aviation and JPL conducted some aerial measurements to determine the emission flux of methane that was occurring under the SS-25 leak. And then CARB also continued to conduct aerial methane surveys across California, including Aliso Canyon. And they just released their final report just last couple months ago. And you can find that information on their website. This is kind of the take-home message chart that goes over all the 4 different air monitoring options and kind of gives a checklist of all the different priorities that were mentioned and gives an idea of relative cost in the cost column with the dollar signs, and also kind of gives a time profile of how long these measurements may last. We're hoping to have that time frame filled out a little bit more with the OpenPath systems. The AG tried to coordinate some cost estimates. We weren't able to get those for you today, but we're still working on that. And the time frame in terms of number of months that measurements can last for the mobile platform and aerial platform will be based on such factors as how often per year you would like to have those type of mobile measurements. Obviously, the more frequent you do those type of measurements, the less number of months total the measurement period can last. So, this is definitely a good slide for consideration when looking at priorities and looking exactly in terms of what the community would need. And these costs were associated if only this one method were used, for example, for the fixed site monitoring. And, you could provide input to say, does a combination of strategies make sense? So, that's all for discussion today. Because again, each of these different types of technologies and methods and approaches suit different purposes and fit a certain need a little bit better. With that, as was kind of hinted at earlier, South Coast AQMD approved last week on reallocating money originally designed for the supporting health study to augment the air monitoring efforts under the SEP related to Port Aransas. So this is specifically going to the Port Aransas section of the air monitoring SEP. And South Coast AQMD will also be continuing to serve in advisory capacity to the project on the technical scale with regards to air monitoring. And with that, I have my contact information here. I'll give you a few seconds in case you need to copy it, although I saw some of the participants, so I see some familiar names, and it's good